Problem 10.5.5. Determine the product of inertia of the shaded area with respect to the x and y axes. So this shaded area right here is bound by the sides x equals 0, y equals 3 inches, and this side, which follows the formula y is equal to 1/9 x cubed, assuming that both y and x are in inches. So the formula for the product of inertia is Ixy equals the integral of Ixy dA. Now, when we were calculating Ixx or Iyy, one thing we could do was break this shape up into a bunch of strips that all have the same x value or all have the same y value. Unfortunately, we cannot do that with this. We do have to look at each piece individually, which means that we do need to do an area integral. So in this area integral, each piece, we can think of it as a square with width dx and height dy. So the integral dA is equal to the double integral dx dy. Now, because of the way that it's set up, I'm going to do dy dx. It's the same thing. You'll get the same answer, but this way it is a little bit easier. So Ixy is equal to the integral of xy di dx. Now the reason I'm writing it like this inner integral says that for a given value of x, I can find the product of inertia of the strip represented by all points at that same x. So for a given x, I can find the moment of inertia of this strip, for example. And that's the inner integral. And the outer integral is integrating all of those strips together and getting a result. So the inner integral, the integral of just this strip, I am integrating from this bottom point from x equals 0 up to the top point, which is given by y equals 1/9 x cubed. So the bounds of integration of the inner integral are from 0 to 1/9 x cubed. For the outer integral, we ignore this bound altogether because this boundary only describes how only affects these vertical stripes. Horizontally, x can be anywhere from 0 to 3 inches. So the outer integral is from 0 to 3. I'll repeat that. The inner integral is bound by what are the possible values of y for a given value of x. That's why the boundary of y depends on the value of x. But because we've already done this integral, this is the innermost integral, this is the first integral we do, the outer integral, we only ask what are the possible values of x, period. All right, so, and at this point it just becomes a not so simple, but relatively straightforward. Take the integral of xy, x is a constant, so I can pull that out of the integral. So the integral of y dy is 1/2 y squared. 1/2 y squared. Use the bounds of 1/9 x cubed and 0. So plugging in 1/9 x cubed in for y, we get 1 over 81, or because there's that extra 1/2 there, 1 over 162 times x cubed squared, which is x to the 6th power. So the value of this integral, of this inner integral, with these bounds, is 1 over 162 times x to the 6th power. And if you'll pardon me, I just noticed a little mistake I made, but I've corrected it. So the integral of x times 1 over 162 x to the 6th power, well, that x turns that into x to the 7th power. Integrate that becomes 1/8 x to the 8th power, which when combined with the 1 over 162 gives an indefinite integral of 1 over 1296 times x to the 8th power. Plug in 3 for x, and you get this as our answer.